Hello everyone, welcome to day 4 of this Unit 1 One-a-Day session. In this video, I'm going to use this particular popular um, exam question, and it's always stating static equilibrium. Static means it does not move, okay? And the only reason it does not move is because the moment that is going anti-clockwise, so imagine you're sitting there, what that does is actually going to turn. Okay, it's not going to go down, it's going to turn, yeah, because there's a pivot. So this turning motion is called moment, but is in the anti-clockwise, so counterclockwise. Whereas this force here, if you're standing there, it's going to turn this way. So this moment here must be clockwise. So when this beam doesn't move, not doesn't have to be balanced, uh, um, well, actually, it would be balanced. Then it is in static equilibrium, meaning whatever is on the left-hand side is the same. The moment is the same as the uh, clockwise. So therefore, what you should start off with always is that sum of moment must equal to 0 under static equilibrium condition. And what does that sum means? It means the moment counterclockwise plus moment clockwise must equal to 0. Okay? So what's moment then? Moment is force times distance. So we're going to focus on moment on a clockwise first, counterclockwise first. So that is equal to 12 times 5, so distance from the pivot here, so 5 times 12, 12 times 5. So what I'll do is I'm going to keep the multiplications using bracket, so 12 times 5, add 20 multiplied by 2. And that's it, that's the two forces. So then I can work this out to be 60 plus 40. So that will give me 100 Newton meters. Because force is Newton and distance is meters, so Nm. Then we do the sum of moment of clockwise. So that would give me 4 times F, so 4F. Okay. Now, sum of moment equal to 0, meaning the left-hand side must equal to the right-hand side as well. Also, so essentially, MCCW, since MCCW must equal to MCW, so I can then write 100 and 100, forget about the units for now, must equal to 4 times F. So to solve these equations, you divide both sides by 4. And then F as 4 divided by 4 is 1, so it's 1F. So F is equal to 100 divided by 4, which is 25 Newton. So that means the missing value F here is 25 Newton. And that is it. Now, in the exam, you have to be careful. There's also the so-called uniform distributed load. So that's the more, slightly more, give you more marks if you like. So it's set up as this symbol here. So essentially, because the load is quite wide, so you have to find out the average, which is, well, it is the load centered at the position of this width. Okay, so normally it would say 15 Newton per meter. So therefore, if this width is 4 meters, then the center of the load would be 50 Newton times 4, and then that's 60 Newton. Okay, so you use this position in the center. So whatever the distance from the pivot to here is, you have to work out that distance and then times by 60, so that you find out the uh, overall load in the middle of the uniformly distributed load. Okay, but hopefully you'll see a question not so long in the future, so I can show you that again. But this is how you show 5 marks. So this is very important. This is worth 1 mark. Thank you for watching. See you next time.